Friends, hello and namaskar. I am Professor S.G. Kulkarni. We are looking at the basics of short staple spinning with special reference to cotton. So this is the fourth unit, basics of blow room. Now we will see in this presentation. In this discussion, we will go through that. Now, as you can see on the screen, blow room is the first step in yarn production. But actually, just to have a look at the preceding stage, we are required to know that in the spinning mills, especially in the context of cotton, we are discussing, the cotton spinning mills have a program for the mixing also. So, as per the count that is going to be spun in the department, as per the production planning, we are required to have evolution of the mix. Evolution of the mix in the sense a particular count, say for example, we are spinning tens carded, any. For that, how many number of cottons should be there? What should be their proportion of mixing? And then after once this program is evolved, actually this is part of process control in spinning or process management in spinning. But at least in this beginning, we must know that single cotton component is very rarely used. One such example is in some of the mills which I saw, MECH cotton was used for spinning of certain counts. So, but overall, in general, we are evolving some mix. We are deciding the recipe actually in a very simple words, and then after letting that mix to remain for 24 hours in the mixing room aside the blow room, then the blow room process actually starts. And in the blow room, there is a sequence of machines. Now, actually, if we see a very orthodox, very conventional spinning unit, where we can see that there were a series of machines which were used. Actually, in today's situation, you may not come across such blow room. Today's blow room is a single step blow room line actually in real words. And this has happened just to discuss a prior history of this. Actually, when F. Liefeld published his paper on this in Journal of Textile Institute and Mellon International English, then really this particular concept got revolutionized, and blow room has become a very short line then. Earlier, at least 6 7 machines were there in the blow room. And what for the machines were used? To start the spinning process. And to start the spinning process, as I have mentioned in this slide, we are going through the blow room's objective, that is to mix and open and to some extent clean the cotton. So mixing is first priority, thorough mixture of whatever number of components as I have discussed just now, how many components are going to be there in that blend, and then mix them thoroughly, then open up them, and then perform certain degree of cleaning. As I have mentioned here, 40 to 70% cleaning is accomplished in the blow room line. So these are the objectives of blow room actually. So functions, objectives, how that is performed in the blow room line, that's what I have mentioned here. Opening the compressed bales of cotton fiber. Usually we know 170 gram is the bale weight. We are required to, as in the earlier unit number 3 we saw, from the field, from the field the cotton is collected, it is compressed, that is ginning is done and then compressed into a bale form for ease of transportation, and then it is being brought in the warehouse of a spinning mill. From that warehouse, as per the program, it will come in the department, mixing and blue room department, and then further things will be done on that. So that is how the sort of a very short sequence is there. Now in the modern blue room line, this is second step is very important, detecting the metal objects in the fiber. This is very important part. To extract and dislodge the metal particles if at all they are present. So cleaning the fibers by removing the dirt, dust. Now here in today's blue room line, the trash is also classified. There is a classification of trash also. 15 microns and below, it is called as a micro dust. 15 micron to 50 micron, it is a fine dust. 50 micron to 500 microns, it is a dust. And above 500 microns, it is called as a trash. So that way, the today's blue room line, unlike the earlier conventional blue room lines, it is treating the trash in the cotton in this way. So mixing and blending different classes or grades of fibers, removing foreign fibers, plastic contamination. Now contamination removal is again a very prime function in today's situation. So that is that we are required to keep in mind. For this, machinery arrangements are there. The today's manufacturers, different manufacturers, they have specific machines for these particular objectives. Uniform feeding to the next stage, that is the carding department. And within the blue room line also, whatever opening has been done or whatever extraction of certain materials which are not intended in the next stage to go, whatever extraction is done in that proper stage, means once one machine opens to a certain degree, on that the next machine will act. So this is what the philosophical change is there in today's blue room lines. So we are required to keep these things in mind. So simply opening cleaning is not merely the objective as it was seen in the conventional lines. That's what is the point in this one. Now we can see various sequences are there actually of these various manufacturers. Conventional line on the right side of the screen, you can see automatic bale opener, automatic blender, step cleaner, axiflow cleaner, porcupine opener, hopper feeder, and scutcher actually. That was the conventional line. Now, while treating, again, one more point was considered. In the conventional line, it was said to be a particular opener or beater was said to have a beating point. And in this line, of course, blender was not having any um, beating point, or bell opener also was provided with a beater, but it was not assigned with a beating point. Axiflow cleaner, porcupine opener, etc., etc., they were assigned some beating points. And step cleaner in this, which was a free flight beater in today's language, that was given a half beating point. So that difference is there as compared to the conventional line in case of today's situation. So reader has uniflock, which is the bell opening device, bell opener, then metal and fire detector, unique clean. This is the first free flight beater, you can say, which doesn't grip the material but beats the material. Then Unimix is the blender, and then Uniflex, where intensive beating takes place, and then it goes to the next department, that is the carding through chute. In case of a Trussler line, whereas BDT is there, Blendomat is there, and then the Axiflow or Axim flow cleaner is Maxiflow cleaner is there in case of them. Then the first step is of course Trussler line is slightly divided here. Either they have CNT system or CVT system. So, and of course, CNT is there, which is a slightly gentle type of a treatment giving machine, and CVT is there, CVT1, CVT2, etc. etc. They are sawtooth beaters, and they will give a harsher treatment, and in between they have the blender also. So this is how overall is the, say, comparison between a very conventional line, earlier philosophy, and today's philosophy. Now these two lines, modern lines, Ritter and the Tuzler, they are provided with a certain computerized program also. So Vario set, and uh, in case of Tuzler also, that is there. So normally what is set is what kind of beater speed you require, what kind of settings you require in between the beater and the assisting element, which was in the conventional line, which was called as a grid bar, and how much intensity you need at a particular given stage. So this is what is decided centrally for that particular blowroom line. Now, in case of Tuzler, in addition to that, we have what is called as entrapment of the trash. Entrapment of trash means once the flock is open, the tuft is opened, whatever trash is released in that beater chamber, it is sucked by the stationary sucking unit there. So this is what again a philosophical change in today's line. So wherever it is liberated, the trash, what kind of trash you are liberating, it is getting rid of, the cotton is getting rid of that trash instantly, you can say. So that's what is the difference in case of these various lines. Now this is the overall picture in a particular given line. Say BALE opener is there, as you can see on the screen here. The BALE opener is there, and this BALE opener will have a traversing mechanism underground. Say the suction lines are there, and when the BALE opener traverses, the chassis comes down of the BALE opener, it plucks certain amount which is pre-feed to the system, that how much quantity is to be plucked per stroke of the BALE plucker, that is also set in this panel here. And then the traversing speed is also fixed. Say it depends actually, but traversing speed is normally it varies in between 9 to 10 or 30, even certain cases, meters per minute. So it depends actually. So this traversing and lowering of the chassis to plug the cotton, and when this kind of a BALE opener in Ritter line, you have some difference, and in Tuzler line you have some difference, that one roller is provided in one instance and two rollers are provided in another instance. So that again difference is there, philosophical difference is there. So in a overall, in a nutshell, the BALE opener will traverse, say, blendomat, etc., and then while traversing, it will plug the cotton, it will be lifted up, it will go through the duct, and then it is sucked, and then it is going to the next, that is the pre-opener. Now, in case of pre-opener, as I have earlier discussed here, pre-opener you have a free flight beater. So gripping and beating is not there in case of pre-opener, and that pre-opened tufts are then taken to the what is called as the mixer. So in the mixer there are different chambers. These two different manufacturers, they have different kinds of philosophies. Here what is peculiarly adjusted is the blending delay time, and blending delay is taken here, it is done here rather. And in these compartments, each compartment, the tufts will fall down as per the requirement, and the height is adjusted and sensors are there. So centrally, the whether feeding is required or not, that sensing is there, and per chamber whether cotton is to be dropped or not, that again is adjusted through some pneumatic sensors, etc., thermopneumatic sensors, etc. And then further, in the end, that particular cotton mixed thoroughly will fall on the bottom on a conveyor, and each compartment will stack the cotton on that conveyor, and from there it is taken ahead, and while its trajectory out, it is beaten up by a beater there, and then it is taken to the intensive or fine cleaners, so where actually gripping and beating will take place, and then from there onwards, the cotton will traverse to the next department, that is the carding department. So overall, there is a sequence of operations here in the blue room line, in modern blue room line, that we are going to see in the succeeding stages. As I have stated earlier, that the variety kind of different particles are there in the trash. At the same time, also we are required to remember that not only this kind of various trash particles are there, but at the same time, when the cotton is picked from the field farm, at that time some extraneous outside contamination also takes place, and sometimes, of course, rarely, deliberately the adulteration is done. So these two factors also we are required to keep in mind in dealing with the today's blue room line. So just now we saw the sequence of a complete blue room line with two different manufacturers and their differences of their philosophies. So today's machines, again I have mentioned, today's machines are equipped with some computer controlled programs, central operating systems also. So opening is the first operation of the blue room to open up the flocks or the tufts so that they can be nicely presented in the next stage, where actually carding's job should be made very easy. So the primemost objective here is to separate out the extraneous matter which is undesirable, extraneous matter in the sense which is not required in the spinning process, not to be spun in the yarn. And secondly, the tufts, clumps, that is, they should be in a such an open state that carding does its job very comfortably. So this is what is the objective. So principle actually here is various kinds of principles are used actually in case of modern blue room line. So gripping, tearing apart, etc., etc., these various different 4 to 5 different kinds of principles are used. In them, actually what is done is two broader principles are accomplished or tried to be used. One is principle of gravity and principle of aerodynamism. Principle of gravity is, as trash is heavier in nature as compared to the opened cotton, so obviously the trash will drop down due to the gravity. And secondly, aerodynamics means the design aspects of certain parts of the machines, even not in the machines also, but when the cotton is transported from one machine to the other machine, during that process, how the trajectory of the cotton is there, how cotton is moved from one machine to the other machine in the duct. So there also this advantage is taken of the aerodynamism, that trash being heavier as compared to the opened cotton. So in that trajectory of transportation, the trash is likely to be ejected out. So these kind of the principles are used, and plus gripping, tearing, ejecting, etc., etc. These are the methods through which the cotton is made to open. Now cleaning process actually, as just now I have mentioned, it depends upon what kind of materials they are adhered to the cotton fiber. For example, seed coats are there. Seed coat fragments means when the ginning is done, the cotton is separated from the seed. But during that process, the certain seed coats they are still remained. They are left in the open. I mean the separated cotton. Actually, a very good research was done at Atira, Ahmedabad Textile Industries Research Association. And what they found out there was there is what is called as a chalajal region on the cotton seed. And this is the weakest point on that seed. And that gets ejected along with the cotton. So it doesn't allow the cotton to go singly, but it accompanies the cotton. So this is what the principle of opening to grip in a certain way, and principle of cleaning is to make the trash to leave the cotton. These are the two broader things as far as the principles are concerned of the blue room line. Now, working principle of the Uniflock BDT or automatic bale opener. Now, Uniflock is from Ritter, BDT is of course from the Tuzler, and some other companies like LMW, they have automatic bale openers. Now, in this zone, the basic function is to open the fiber from the bale. As just now in the overview of the modern spinning plant, I have discussed the bale openers, whatever, whether they are uniflock, single beater type, or double beater type, or double beater type, etc., etc. Combination of the openers is there. They are sawtooth, covered, or some other kind of coverings are there on these openers, the bale openers, etc., etc. So this opening device is to penetrate into the bale, as I have mentioned earlier also. Each time when the traverse is complete of the bale opener from one end to the other end, and this particular process, how many bales are placed there at one time, this is called as a bale laydown. A bale laydown. And actually, bale management function is also there, that for a given particular type of a count, how many types of bales are required, how they should be laid, or there is other program also developed by Atira again, linear programming technique, just to evolve what kind of a mix is there and how many bales where are required rather to work out for a particular certain given count in that department. So production capabilities, etc., they vary. 10 gram per tuft in this zone is it is expected actually. No beating action, but picking is performed here. Certain beaters all are also provided there. So this particular department or this particular machine will be something looking like this one, where this task is done as a first part to provide to the next machine in case of the modern bloom line. This functionality is very important because based on this openness, how much tuft size is opened here, the next succeeding machines, whether it is a foreign fiber detecting device or the metal detectors are there, etc., etc., they will be functioning very properly depending upon what function the bale opener has done, whether it has done reduced the tuft size, picked up the correct tuft size, etc., etc., that is governed by that. So this is a very important point and first machine in case of this one. So traverse speed, as I have earlier mentioned, it will vary in modern say bale openers that has gone up, and speed of take up roller, what picks up the material, etc., that again, now these are slightly conventional figures in today's situation. Say latest machines, these figures have gone up, but functionality has remained the same. The production pattern, again, very important factor here is Blueroom many times is a start stop process in even in the today's situation also. As per the requirement at the carding, say 8 cards are fed by one blue room line, then depending upon the quantity of material required at each card and production rate of the card also, that is to be taken into account, how long a particular machine will work here in the given blue room line, that is decided or that is done. Now, whether a particular machine will work or not, that particular data or signal will be obtained from the next department, and that is given in a sequence to this particular machine. Now again, I have mentioned here, this was a additional point, as I have mentioned here, nominal takeoff depth, that per stroke how much that chassis of the bale opener will descend down in the bale, that is this 2.5 to 3.5 millimeter. It largely it is governed by what different combination of cottons you have, etc., etc. So that is what is the bale opener functionality. So as we can see here, the Trussler system of bale opening, once the direction is there on the travel direction, that is the transportation of cotton is on the right side, the left roller will lift. So two roller system they have used here, and overall the traverse depth of penetration and the suction pressure, that will govern the various parameters variables in case of this Trussler system or any other the bale opener system. So this is how the bale opening is done, and this opened bale cotton will be transported in the ducts and taken to the next system, next machine, that is. So working principle of the metal and fire detector. Now in case of this one, in modern blue room lines, as I have told, that these installations are not remained as optional now. Earlier they used to tell that this is optional installation, but today it is somewhat it is mandatory, you can say, for the industry protection, etc., etc. And again, say as I have said in case of the earlier situation, that what kind of roller systems, the beating action, etc., you adopt. The Vario set is there in case of the reader, and the C factor, cotton cleanability index, and machine performance, that is considered in case of the Trussler line. They normally rate rank on the say zero point 0.1 to 1 scale, etc., etc. Wow, 2.5 I think. So these scales are there. So depending upon what kind of intensity you want, the these particular factors are required to be adjusted in the centralized panel. So here in the metal separator or fire detector, where presence of metal is there, obviously you are required to scan that. So once the cotton is transported, it is better to have location of this. In the earlier diagram flow chart, I didn't show this one, but it is better to position this particular machine there immediately after the first bale opener. So a metal separator acts there as say the tuft passes there, as you can see in this diagram, the tuft is passing there, it is scanned, and the nozzles will once the scanning they find that there is a presence of a small metal part, etc., etc., that that will be dislodged. So a larger portion of cotton also will go through this one, but invariably we are required to have this installation there, so that the safety is given the most priority here. Again, we can have say avoid the damage to the succeeding machine parts as well. There are chances of fire also, so machine damage is also prevented. So these installations in the today's situation, they are a must. Now pre-cleaner, or what is called as a free flight beater, a pre-cleaner or free flight beater. Now here, as I have mentioned earlier, in case of Ritter systems, it is Uniflock, the free flight beater. In case of the Trussler, it is say earlier in the conventional days, it was Axiflow cleaner or Maxiflow cleaner. So what here it is done is, once a certain tub size has come with the prior department, BALE opener, and then of course the installation of this one, then this particular machine, here we can see we are having a Trussler line here. So what we are seeing here is a Maxiflow cleaner. So introduction of the cotton will be done in the chamber of this beater. Earlier you have a gripping point, it grips there. If at all any loose trash is present, it will be dislodged at this place. So this is dislodgement of the trash, and then after gripping and consolidation, opening to some extent in between these two roller lines, that cotton will arrive in this free flight beater chamber. There is a top hood here, and then at the bottom you have assisting element and trash collection chamber here. So two beaters, they will spiral the cotton here. In the free flight, they will dash the cotton, so to say, in very simple words, and one roller's cotton, opened certain degree of open cotton, will get transferred on the other beaters. Of course, the needles, as you can see in this diagram here, the roller covering here is of a rounded wires sort of covering is there. These are not sawtooth wires here, and the staggering is there of the wire points also here. So a gentle treatment is supposed to be given here. So this particular roller's cotton will be transferred on this. Again, it will do its beating action, and then the cotton will be taken out. So that particular thing happens, this particular thing happens in the axial fashion. So they they are named, say earlier it was named as Axiflow cleaner, etc., etc. Somewhat improvements are there, like suctions are provided here. Suction is provided here. So at two places the suction will be provided. Here in this chamber, tuft size will get reduced further, and a larger size of trash is likely to be removed here. That's what this particular machine, the it will give the treatment on the material. So as I have described, this particular description is there. The tufts of cotton, they will have their journey, the trajectory there in this beater chamber, in the spiral path, and pins are there as I have mentioned. Now technical data is there, beater speed, what exactly should be the beater speed. Again, as I have stated, C factor and M factor, 0.5 to 2.5, this scale is there, slight improvement I have to do here. And then on this scale, if a cotton comprises of embedded trash, more embedded trash, very hard, difficult to remove trash, their intensity has to be more. Likewise, the considerations are there, and in that case, of course, the beater and assisting bar, that setting will narrow down. Of course, in case of the axiflow or maxiflow, uh, gripping and beating is not there, but still the things are required to be set. Grid bar setting 2.5 to 3.5 mm, they are quite wide apart here. So that is avoided here. Free flight beating is done. Speed of the beater is normally 400 to 800 revolutions per minute, and the diameters of the beater are 700 to 800 millimeters. These dimensions they play an important role because the size of the beater, the length of the beater, and the input speed and the output rate, that decides entire this consideration, decides all the speeds, they decide what exactly is residence time of cotton. Residence time of cotton in the sense how long the cotton will remain in contact with the beater and it will perform its action. So this residence time, that will that residence time will govern everything, that how far that cotton undergoes that particular given treatment is decided by that. Yes. So we'll go to the next. Now working principle of multi-mixer. Now multi-mixers say job earlier in the flowchart also have discussed that to have a blending delay time, in very ordinary words, how thoroughly the mixing will take place, that is their function. So what kind of arrangements, the number of chambers, the input speed, the dropping of the material in a given particular chamber at a given time, and the traverse speed of the bottom conveyor, and then further beating of that, and delivery speed, they all govern how much a single tuft gets the time to mingle with the other tufts. This is what is the basic of this functionality. So that is what is done. Mechanical it is tried to be done. It is say it is to be obtained. They try the thing to get done in the multi-mixer. And multi-mixer because you have a number of chambers there. So in case of this one, we can see in this diagram a multi-mixer is shown over here. So here what we have, the input of the material from the previous department, that is if you have a say pre-opener etc., then blendomat pre-opener, and in between if you install a foreign fiber detection system, from there now the material in the reduced tough form will arrive here in this chamber. Now here you can see inflow of the material. Here suction is provided in the beginning itself. The material will get its trajectory, and each of this compartment you have what, the inflow of material, in each compartment. And you can see here in these different compartments, 6 compartments we are seeing here. In these different 6 compartments, to start with, a different level of stacking of cotton is there. So these pressure transducers, they will sense and adjust different level of stock, the stock of cotton in this chamber, each chamber here. And that does what, it gives a particular mixing. Suppose we have 3 different components in the cotton mixing. One is say 60%, other one is 30%, and third one is 10%. So it makes 100%. Now of this, 60% might be predominant in the mix. It might be observed, found at every place. So that should not be the case. Once we randomly take any cotton tuft lot at any stage, you should be able to find in that proportion itself, the cotton should be found in that. That's what is the basic philosophy behind this one. And that's why mechanically what arrangement is done, that is what is shown over here. So each chamber one can see, of course, level of stock of cotton in each chamber is controlled here, as I have stated, and that can be visibly seen also in this one. And at the bottom we find here two beaters which are thrusting the input rollers, you can say, and they are thrusting the material on the beater at the very bottom place. And now at the bottom there is a conveyor, here, and after the treatment at each of this beater in conjunction with the bars below them, the opened up material will be deposited on the conveyor at the bottom, and each chamber will go on dropping its material as the height is different in each chamber. So chances are increased that thorough mixture will take place, and then at the exit the material is sucked and taken in the next department. So this is how the philosophy of this particular multi mixer is there. More or less the same things are there in different manufacturers, but basic philosophy remains the same. So this is how about the multi mixer. Now technical data is mentioned over here. The storage volume per chamber is 1.4 to 2.6. Storage volume per chamber. Storage capacity per chamber is 40 to 80 kilos, which is a huge quantity. And storage speed of opening ruler 1000 to 1200 revolutions per minute of the opening roller in each chamber at the bottom side. So at that speed, that will thrust the material down to the next. So homogeneity is obtained, as what in the layman's term I have stated, that any tuft you take at any time, any place, you should find the same proportion in which they are available in that particular tuft or flock. So that's what is the philosophy in case of mixing. Now next is the here now when we are discussing about the CVT line or CNT line. Now CVT line is meant for harsh treatment, one can say, and one roller is there or two rollers are there, etc., etc. And CNT line normally is preferred for the sort of a fine cotton, one can say, where trash content is less. So depending upon what kind of count you are going to spin, of course your installation of the blow room is required to be in that particular order. If someone prefers a course count range, say up to 30s or something like that, then that installation should have a CVT line in case of a Trussler. Of course, that kind of a difference is not available in case of a Ritter line or LMW line also. They are providing some different techniques in that particular direction, but these kind of differences we must have. So for example, we are processing a very coarse count like 10s, 12s, etc., etc. Obviously in such count cottons, trash content will be high. And again, further going in details of this, what variety we choose, that will decide how far the adherence is there of the trash, firm adherence or less firm adherence of the trash with the cotton fibers. This depends upon again the kind of variety we are choosing. If you are consuming Indian cottons, that thing is different. In if you are consuming say foreign materials, foreign cottons, then that situation is different one. So what I have mentioned here is the smallest size to clean and the greater extent removing smaller size of the trash and dust which are trapped between the fibers. The basic philosophy followed in the beaters. Now this we are going towards now intensive beating, one can say. Free flight beating once we saw. Now intensive beating we are going for. Again in that some classes as I have mentioned they are there. Now again in that what kind of treatment you require, whether you require a high C factor or M factor in case of a Trussler line, or you say require a more relative amount of waste versus cleaning intensity in case of a Ritter's varioset, that is to be say seen upon. And accordingly the machine, they are designed. And here what I have mentioned here is three rotating beaters are there which are sawtooth covered, means this is a CVT line, so which is used normally for coarse cottons and the cottons, especially Indian cottons, which are comprising of very hard to remove trash. And the speeds etc., again I have stated in the earlier case also that the speed setting, these are the philosophies which are required to be understood in case of a blow room line. The distances decide how much is the intensity distance between the beater and the assisting element, the grid bar in the conventional lines, that decides how intensively the cotton will be beaten up in that beater chamber, and then it will go ahead. And what kind of a covering you have on the beater, that will also decide the intensity of beating etc. So this is what, these are some of the quotations which are there, the speeds and the microgram, the removed etc., tuft size removed etc. Opening the tufts and getting rid of the trash is the basic philosophy in any intensive beating line, whether what kind of manufacturer you have. So that's what is the diagram here. It is shown in this. The input of the inner trajectory of the material is there, then a sawtooth opener will consolidate the material. This is again to some extent one can say it goes in conjunction with the conventional line, that feeding, what sort of a feeding one has to have. So though that way the more or less same situation is there. Now you can see here, once the cotton enters in the beater chamber, intensive beating chamber, which is sawtooth covered, assisting elements, grid bars or knives are there, as you can see clearly here. And these two balloons, which are very, very important in the Trussler philosophy, they, whatever trash is released here, whatever opening has happened, what distance is there in between these two rollers, feeding rollers, and what intensive beating takes place, and the cotton is taken in the forward trajectory, what trash is released in the first beater chamber itself, that is got rid of. Means wherever the trash is released, a suction will be provided and that will dislodge the trash there itself. So in sequence that will go on happening. For the second beater you can see at the top the suction is provided, suction intensity etc etc, that is another setting that is required to be done depending upon what beater speed you have and what distance here is there in between the assisting element and that beater etc, and what intensity of the trash is there to get adhered to the cotton etc. So after the treatment, intensive treatment, the tuft size has got reduced now, and more or less whatever 40 to 70% cleaning efficiency earlier we had discussed in the modern blue room line, that has been achieved by this stage. Most of the foreign fibers or metals, if at all they were present, they are got rid of, and then this reduced tuft size of the cotton, that will go in the next chamber, next department. So just now I have mentioned about the working principle of this one. The trash is taken care of wherever the say the suction is required, that will be sucked and that will be taken ahead. So this is now working principle of the, if at all we are installing the, one can say the foreign fiber detection device, then more or less that will work in the manner, the pattern in which the metal detector has worked. Here, slight differences are there. Earlier, also, I have mentioned about this one, that if at all a camera detects this, once the material is coming inside this chamber, once it comes inside this chamber, the camera color module, the camera will detect foreign fiber if at all it is present there, and whatever with the pre-fetched data it will assess, and then as per that it will go in the next chamber. Next chamber you have a nozzle bar. So once detection has taken place, of course, the cotton has been opened very spread, and then it is opened, thoroughly opened, and the spread tufts, if at all they are having some foreign materials in them, that will be detected by this CCD camera, and then nozzles will dislodge that. A single nozzle line or double nozzle line is present there, and after dislodgement of that foreign fiber portion, then these opened tufts they will move ahead. So this is a foreign fiber detection device that is placed here in this modern blow room line, and then this material will go, opened up material will go in the carding department. Now there is working of the cleaning efficiency. Though we say that opening and cleaning, traditionally we say that opening and cleaning is the function of blow room. What is measured of the blow room is the cleaning efficiency. Opening is indirectly accomplished. It is obtained. That's why cleaning has taken place. So trash in fed minus trash in delivered divided by trash in fed, that is how we work out the cleaning efficiency of the blow room. And overall, for a given BALE laydown, as I have mentioned earlier, in the BALE plucker, in the very first machine, there is a certain BALE laydown. You can go up to 300 bales even in the today's situation. So we can calculate what is cleaning efficiency. If this cleaning efficiency is attained depending upon what kind of trash was present in the cotton, then we are satisfied with this. This is of offline test, and then we are required to go further to the next department, that is the carding department. So cleaning efficiency measurement is most important functionality, indirect assessment of the performance of the blow room. So main factors considered in the blow room are number of opening machines, types of beaters, beater speeds, production rate of individual machine, that will vary from machine to machine, kind of function that machine is assigned, obviously it will vary. Then fiber micron error plays a vital role here, as it decides how far or whether damage will take place to the fiber or not because of the blow room treatment, that is being considered here. Type of grid assisting element or grid bars and grid bar setting, that distance plays a very important role. It decides about the intensity of the beating action, position of the machine in the sequence, what kind of machine, previous machine feeds to this machine's efficacy will be decided. Amount of trash in the fed material, temperature and relative humidity in the blow room line, that decides about the affinity with which the cotton will have with the moisture, and that will, whether it will provide easiness for trash removal or not, this is being considered. So this is what is the discussion on the modern blow room line. Some of the very highlighting points I have discussed here, we will see in the next, that is the carding department.